This is the experiment that Rutherford did, which proved that positive charge of atom is in the center. It's in the nucleus. And electrons are making the rest of the atom. And then we talk about this. These are all things that we talk about. This is the conclusion. This is today's lecture. So after discovery of the charge of electron by Mulliken, after discovering the mass of electron by Thomson and Mulliken, then mass of proton was measured. Later on, Chadwick, as we said on our Wednesday lecture, discovered neutron. And neutron were neutral, they didn't have a charge, it was harder to detect them. Eventually they detected. So that's what we know, and it's still not proven wrong, that atoms are made out of electrons, protons, and neutrons. Mass of proton and neutron are almost close together. They're almost identical. And when you compare the mass of protons and neutrons with mass of electrons are almost 2,000 times lighter. So we assume mass of the atom is mass of its protons and neutrons. Electrons don't have a lot of mass. We assume they have zero mass. And then, as you might have noticed, we are still reviewing what you had in Chem 2A. We define atomic number as number of protons. In a neutral atom, our elements have neutral atom, number of the neutrons and, number of protons and electrons are equal together. So if I give you Z, Z means number of protons, and you can calculate number of electrons. Another definition, mass number, is total number of electrons and protons. I'm sorry, I think I got upset for the fact that the PowerPoint got frozen and now I keep making errors. So mass number, one more time, is number of protons and number of neutrons. We show mass number with A, atomic number, just to confuse you, atomic number with Z. So can I say that mass number is total number of the protons and neutrons? We also said atoms of the same element are composed of different atoms, which are only different by the number of neutrons. So we call them isotopes. So when we are showing notification for a specific isotope, we show atomic number on the bottom left. Atomic number on the bottom left. This shows number of protons. And we show mass number on the upper left. This shows number of protons and neutrons. If you want to calculate number of neutrons, you just take the number on the upper left minus the number on the bottom left, you get number of neutrons. Although you know this is not the symbol we use in periodic table. Periodic table, there is a different arrangement I will talk about. But this is how we show different isotopes. This is how we show characteristics of any atoms. So X is the symbol for the element, And the upper left number is mass number, number of protons. And the bottom left number is atomic number, number of protons, number of neutrons, and protons on the top. So if I say hydrogen 1, 1, it means this hydrogen has got 1 proton, 1 electron, and no neutron. Because I take upper number minus lower number, I get 0, no neutrons. And this is another isotope of hydrogen. It's a heavier isotope, as you see. The mass number is 2. And atomic number is suggesting there must be 1 proton and 1 electron, and 2 minus 1, mass number minus atomic number, I'm going to get 1 neutron. And hydrogen 3, tritium, is another isotope of hydrogen, and it has got a mass number of 3. So if I get 3 minus 1, I get 2 neutrons. So 1 proton, 1 electron, and 2 neutrons. So this hydrogen is radioactive, this isotope. So in fact, if you are drinking waters, there are certain small amount of hydrogen 3 H2O. So that is used for making hydrogen bomb. If you can break down water, separate tritium, this is called tritium.
So I had a quick question.
Yes.
So if something is an isotope, does that mean it's radioactive, or is it just some isotopes can be radioactive?
Isotope is used for different atoms of the same element. All elements have at least 2 isotopes. So isotopes are not radioactive necessarily. Some isotopes are radioactive, some are not. Isotope simply means different atoms of the same element which have got different number of neutrons, and that is the case here. These are 3 isotopes of hydrogen.
Okay, gotcha. Thank you.
What is difference? Sure. What is difference between them? One has 0 neutron, the other one has 1 neutron, the other one has 2 neutrons. That's all it means. Radioactivity property is not related to number of isotopes. Some isotopes are radioactive, some are not. Thank you for asking.
Yeah, thank you so much.
My pleasure, thank you. So if I say uranium, uranium has these 2 isotopes. This is the isotope. They're both radioactive. But this one is the one that you use for making nuclear bomb. And you make nuclear rod as well, nuclear reactor rods. This one is majority of uranium. It is radioactive, but you cannot use it for making bomb. So if you want to make, you actually get the uranium or you purify it. If you make 5% uranium-235, it can be used for nuclear reactors. And if you make it 95% 235, then you are using you can use it for nuclear bomb because it's fissionable. Uranium-238 is not fissionable. Uranium-235 is fissionable, and it can cause, you can use it for producing energy or for a nuclear bomb. So this is the difference between 3 isotopes of hydrogen. All of these are isotopes of hydrogen. Some of them are heavier than others. Some of them are more abundant. Most of hydrogen that is in water or any other compound is hydrogen 1. There is some hydrogen 2, deuterium, and there is tiny amount of hydrogen 3, tritium. So guys, if I ask you how many protons, neutrons are in carbon-14, by the way, we name different isotopes by their mass number. So this is called carbon-14. How many protons in carbon-14? Can I say 6 protons? How many electrons in carbon-14? Same number of electrons as protons. How many neutrons in carbon-14? All you have to do, subtract 6, subtract 6 from 14, you get 8. That's number of neutrons. Why? Because upper number, mass number, neutrons and protons. Lower number, number of protons. The difference between these two will give you number of neutrons. Is there such a thing as carbon-11? Yes. That's one of the isotopes of carbon. Could somebody tell me how many protons in carbon-11? How many protons in carbon-11?
6.
Thank you. Good job. 6 protons, 6 electrons, number of neutrons, the difference between mass number and atomic number, the difference is 5. So 5 neutrons. So go guys, let's see if you can answer this. Raise Zoom's hand so I know how fast you're getting these. Thank you, Victoria. Victoria, you were the first who got it. Excellent. Good job, guys. Good going.